Here's something that'll make you question everything you know about your oil change. Take a 2021 Toyota Camry with the 2.5L engine. In the United States, Toyota requires 0W-20 oil. That same exact engine in the same exact car sold in Japan. The manual specifies 5W-30. Same bearings, same tolerances, same pistons, but drastically different oil specifications. The automotive industry's shift toward 0W-20 specification stems from stringent corporate average fuel economy standards requiring manufacturers to achieve 40.5 miles per gallon fleet averages by 2026. Research from the late 1990s showed that 5W-20 is only 1.5% more fuel efficient compared to 5W-30. On a car rated at 30 miles per gallon, that's a difference of less than half a mile per gallon, something most drivers would never even notice. After 25 years of working on engines and watching this transition unfold, I'm going to show you exactly why American cars use oil that's thinner than what the rest of the world trusts, what it means for your engine's longevity, and whether you should actually follow your owner's manual. This isn't about conspiracy theories, it's about regulatory pressure, corporate compliance, and the trade-offs nobody talks about. Let's break it down. Before we dive into the controversy, let's establish some technical foundation. Motor oil viscosity is rated using the SAE J300 standard, a system created by the Society of Automotive Engineers. The W stands for winter. 0W-20 means the oil flows efficiently at extremely low temperatures, while the 20 indicates its viscosity when the engine reaches operating temperature. 0W-20's 20 weight flows like water at 212 degrees Fahrenheit, while 5W-30's 30 weight maintains a thicker protective film, a 50% difference in hot viscosity. That's not a small difference. That's the fundamental trade-off: maximum efficiency versus enhanced protection. In Europe, you wouldn't find even 30-grade oils in supermarkets. It's 40-grade, sometimes 50-grade oils all the way. Walk into an auto parts store in Germany or Spain, and 10W-40 is the most common grade. Meanwhile, American shelves are dominated by 0W-20 and 5W-20. Southern Spain has temperatures similar to the Southwest United States, yet 20W-50 is widely used. The question isn't what works, it's what are we optimizing for? CAFE standards require manufacturers to achieve 40.5 miles per gallon fleet averages by 2026. Fail to meet it, and manufacturers face substantial penalties. CAFE standards require that the oil the car is certified with is the oil that owners must use, and manufacturers must make every effort to ensure owners use it. That's why you see one viscosity grade stamped on your oil filler cap, regardless of climate or driving conditions. Research showed 5W-20 is 1.5% more fuel efficient compared to 5W-30. On a 30 miles per gallon car, switching to lighter oil would result in 30.45 miles per gallon. Most drivers would never notice the difference. Mobil 1 states that 0.2 to 2.3% fuel economy improvement can be obtained by switching from higher viscosity oils to a 0W-20 grade. In real-world terms, a car with a 20-gallon tank might go up to 9 more miles per tank, equating to around 250 more miles per year. Manufacturers need every fractional improvement they can get when averaging across millions of vehicles. 0W-20 reduces parasitic losses and helps them meet federal requirements. Many experts believe that 5W-30 offers better protection under many driving conditions than the thinner grades being pushed for efficiency. But engines using 0W-16 and 0W-20 will almost always outlast the vehicle itself. So the question isn't whether 0W-20 damages engines, it's whether it's the optimal choice if fuel economy weren't the primary consideration. Forum members have documented that only North American vehicles use 0W-20, while the same Forester sold in Asia, Europe, or Australia specifies 5W-30 and even 10W-40 in hot climates. According to Subaru Japan, 0W-30, 5W-30, and 5W-40 oils can be used in any Subaru engine, while 0W-20 oils are specifically for environmental reasons. The 2AR-FE engine in other countries without CAFE pressure has a range of accepted oil weights from 0W-20 to 0W-40. Same engine, same components, but a wider acceptable range outside the US. Europe uses thicker oil because many drivers drive aggressively or tow frequently, needing higher HTHS viscosity for protection. In North America, drivers cruise gently and have larger engines under light stress. Many European oils have wider viscosity ranges like 5W-40, 0W-30, and 0W-40, which require higher quality base oils. The Caribbean has higher temperatures than most of the US, yet thicker oils are specified, up to 20W-50. If temperature were the only factor, specs would match. The pattern is clear. In the US, regulatory pressure pushes thin oils. That pressure doesn't exist elsewhere. The rest of the world isn't avoiding 0W-20 because their engines are different. They're avoiding it because they prioritize protection and longevity over tiny fuel economy gains. Quick question: what oil does your owner's manual specify, and what are you actually using? Drop your car's make, model, and year in the comments, along with whether you follow the manual or run something thicker. This is where the protection versus efficiency debate starts. Modern engines have tighter tolerances and higher operating temperatures. Lubricant manufacturers developed modern motor oils focusing on zero-weight grades such as 0W-40, 0W-30, 0W-20, and more recently 0W-16. Modern engines aren't the same as engines from 20 years ago. CNC machining and modern metallurgy allow engines to get by with slightly lower viscosity. Dyno testing reveals 0W-20 reduces engine friction by 12 to 18% compared to 5W-30, with the biggest benefits during cold starts and low-load cruising. The average age of US vehicles is older than ever, and the percentage using 0W-20 is larger than ever. Most cars are scrapped for reasons unrelated to engine, where long before thin oil becomes an issue. However, there are real scenarios where thicker oil makes sense. High-performance driving, towing, hot climates, high-mileage engines, and engines showing increased oil consumption. Real-world testing often shows no measurable fuel economy difference between viscosities because traffic, climate, and driving style overshadow tiny viscosity-related gains. Several long-term testers reported no difference between 0W-20 and 5W-30 in everyday use. High temperature, high shear viscosity is where things matter. 0W-20 is 50% thinner than 5W-30 at operating temperature. For normal cruising, that difference doesn't matter. But during towing, mountain driving, hard acceleration, high RPM driving, or hot weather, that difference becomes significant. Turbocharged and direct injection engines generate more heat and higher stress. Ironically, these engines are the ones asked to run on thinner oils. Manufacturers prefer thin oils to meet fleet fuel economy targets, but also design performance engines that are meant to be driven hard. The engineering and regulatory goals don't always align. If your vehicle is under warranty, follow the OEM recommendation. Using oil outside the specified viscosity range can risk denied warranty claims. After warranty expiration, you have more flexibility. Driving style matters. Gentle commuting is fine for 0W-20. Spirited driving, towing, mountains, or hot weather may benefit from 5W-30. Climate matters. Cold climates benefit from 0W winter performance. Hot climates benefit from thicker 30-weight protection. Engine mileage matters. Under 75,000 miles, follow manufacturer specs. Over 75,000, 5W-30 may offer better wear protection. Over 150,000 miles, thicker oils may make sense due to increased bearing clearances. Synthetic oils matter more than viscosity. A high-quality synthetic 0W-20 may protect better than a cheap conventional 5W-30. Synthetic 0W-20 allows longer intervals than conventional oils. For most drivers, following the manufacturer specification with a quality synthetic oil is fine. But if you drive hard, tow heavy, or have a high-mileage vehicle, switching to 5W-30 after warranty expiration makes sense. Vehicles using 0W-20 show small fuel economy gains over time, but these gains often amount to only a few dollars per year. The cost differences between synthetic 0W-20 0W-20 and synthetic 5W-30 are negligible. You're not choosing between expensive and cheap, you're choosing between regulatory compliance and engineering preference. If using 5W-30 instead of 0W-20 costs a few dollars more per year in fuel but extends your engine life, that's a good trade-off. The challenge is that the protection benefit is theoretical until you encounter a problem. The regulatory push for 0W-20 is about fuel economy and emissions compliance, not necessarily engineering optimization. Engines and oils are high quality today, so both options generally work. But if you want maximum protection and drive aggressively, thicker oil can make sense once warranty is over. The automotive industry's shift toward 0W-20 stems from CAFE requirements pushing for higher fleet fuel economy. Manufacturers must ensure owners use the oil the car was certified with. Identical engines outside North America often specify 5W-30 or heavier oils. This isn't because the engines are different, it's because the regulations are different. Research shows 5W-20 is 1.5% more fuel efficient than 5W-30, translating to less than 0.5 miles per gallon difference. Real-world testing often shows no difference at all. Engines using 0W-20 will almost always outlast the vehicle, but many experts still believe 5W-30 offers better protection in many conditions. Under warranty, follow manufacturer specifications. After warranty, consider your driving style, climate, and engine type. Use high-quality synthetic oil regardless of viscosity. Monitor your engine for signs of oil consumption or unusual noises. The 0W-20 mandate is regulatory engineering, not necessarily mechanical optimization. Modern engines can tolerate thin oils, so it works for most drivers. But the rest of the world uses thicker oils because they optimize for protection and longevity instead of tiny fuel economy gains. Next week, we'll talk about oil change intervals and whether 10,000-mile changes are actually safe. If this video taught you something new about oil specifications, subscribe and hit the notification bell. Let me know in the comments whether you follow manufacturer specs or if you've switched to thicker oil. I read every comment and often provide recommendations for specific engines. Your engine doesn't care about CAFE standards. Give it what it needs, not just what the regulations require.